In the last section in Unit 8, we're going to look at rational equations, and then we're also going to look at rational inequalities. And inequalities are going to be something a little bit new, but you deal with them a lot like you do with rational equations, which you've had rational equations before. So we will look at number 1 first here. So let's zoom in on number 1. And the key thing is we have to remember to check for extraneous solutions. And that really results from what we call excluded values. And excluded values are anything that makes an original denominator 0. Okay, and sometimes you have to get it in factored form for that. If they're monomials, the excluded value is 0. So if you look at number 1, and we're solving an equation here. So kind of some steps to list out, and I have these listed out on your reference sheet, is you want to find common denominators. Okay, like we did when we did just algebraic fractions when you were adding and subtracting. So if I look at my m, my 3, and my 3m, okay, and again, this is a rational equation, so we're trying to solve and get x equals something, or y equals something, m equals something, whatever the variable is. Okay, when you were just doing an algebraic fraction, adding or subtracting, you were trying to combine into one fraction, multiply by what you need to. Here we're trying to solve. You're going to do some very similar steps though. So my common denominator for this first one, I've got an m, a 3, and then a 3m. It's really 3m. So I'm going to take and I'm going to multiply the bottom here by 3, which means I'm going to do the top by 3. This middle one I have to multiply by m, so I'm going to multiply there by m. And I already have the common denominator there. So what we're really doing is we're writing everything over 3m. Okay, and I'm going to go ahead, and we've got that now as everything over 3m. And once you get that, you can really just drop off the denominators because we're trying to solve an equation. You can't do that when you were doing algebraic fractions earlier. So this is 3m minus 9, if I distribute my 3, equals 1 times m is m, and then minus 1. Okay, the excluded value, I'm going to say the excluded value is m cannot be 0 because we have, looking at these denominators, they've either got m or 3m in there, so that's the excluded value. Okay, and you dealt with those in intermediate algebra 1 quite a bit, and a little bit in the algebra review and geometry. So if we solve this and get 0, we have to throw it out. It's called an extraneous solution then. But if I go through, now this is linear, so I'm going to go through and I'm going to subtract m. So 2m minus 9 is equal to negative 1. I'm going to add 9, so I get 2m is equal to 8. I'm going to divide by 2, so m is equal to 4. And we just have to make sure that this is not one of our excluded values. It's not, so it checks out. So I give m equals 4 as my solution. Okay, let's go down to number 11. Right down here. Now, these get a little more complex. You're going to want to factor denominators where you can factor. And that's only going to be the case if they were binomials or trinomials. So right down here, I notice I can take a k out, and I'm left with k plus 4. I can do the same thing over on this one. Okay, and so if you think about your common denominator here, it's really the monomial k and the binomial k plus 4. So I have the denominator in this one and in this one. Notice I've got to multiply here by k plus 4. So I need to multiply here by k plus 4. So I'm going to go ahead and distribute that. So it's 2k plus 8. Okay, and then plus my 1, I didn't multiply anything there, equals 4. So I'm going to go ahead and combine these. And by the way, our excluded values here are what makes the denominator 0. So if this is a monomial k, one of the excluded values is 0. And if I set k plus 4 equal to 0, subtract 4, so the other one is negative 4. Now if I would get either of those answers when I solve this, I would have to throw them out. We call those extraneous solutions. But let's get back to the problem here. This is 2k plus 9. If I combine these, equals 4. I subtract 9. So 2k is equal to negative 5. I divide by 2. So it's negative 5 halves, same as negative 2 1/2. And notice that is not one of these excluded values, so that checks out. And we get k equals negative 5 halves.